Hello, Gen Chemers. This video is going to go over how we classify samples of matter. This is in response to one of your mud card requests, and I hope you find it helpful. If we begin with a chunk of stuff, all matter, the first question you ask is, can it be separated by a physical process? And a physical process relies on a physical property. It includes things like distillation, which is the separation of liquids by boiling point, filtration, which separates solids from liquids, and chromatography, which separates chemicals based on the affinity they have for other chemicals. If your sample of matter cannot be separated by a physical process, what you have on your hands is a pure substance. So the next question is, can it be decomposed through a chemical process? Chemical processes transform the substance into a new substance or substances. Now, these include things like combustion, which uses thermal energy to transform your compound, for instance, gasoline into carbon dioxide and water vapor. Electrolysis, which uses electrical energy to separate your substances. This is one of the ways that we make sodium metal, pure sodium. Or digestion, which uses other chemicals to transform a substance into a new substance. If your pure substance cannot be decomposed chemically, you have a sample of an element. An element contains atoms of only one type. Examples of this include nitrogen, which is a gas, mercury, which is a liquid at room temperature, and carbon, which is a solid. Now, if on the other hand, your pure substance can be decomposed chemically, you have a compound. Now, compounds have more than one type of atom, but it only has one configuration of atoms. They're bound in molecules. A molecule is two or more atoms bound together, and a compound is made out of just one single type of molecule. This includes things like nitrous oxide, a gas, water, which is a liquid, or sucrose, which is table sugar, a solid. So let's go all the way back up to the top. We have another chunk of matter. We say, yes, we can separate this by a physical process like distillation or filtration. So now instead of a pure substance, we have a mixture, and we have to ask, is it uniform throughout? Now, by uniform, we mean on the molecular or the atomic level. If it turns out that yes, it is uniform, you have a homogeneous mixture. Homogeneous mixtures include solutions like seawater, which is salts dissolved in water. It includes the atmosphere, which is an entirely gas phase solution of nitrogen and oxygen and carbon dioxide and argon. And it also includes solid phase solutions like metallic alloys. Brass is an alloy of copper and zinc mixed together. On the other hand, if your mixture is not uniform, you have instead a heterogeneous mixture. This type of mixture has chunks, like a chocolate chip cookie. Heterogeneous mixtures include things like liquids that cannot mix, oil and water. That can become an emulsion like mayonnaise. It can also be a stable blend of a solid and a liquid, like mixing cornstarch and water to make oobleck. And if you're talking about all solid phase examples, these can be composite materials like fiberglass, which is glass fibers embedded in a plastic matrix. So to review, we have all matter up here at the top. If you can separate it by a physical process, it's a mixture. If that mixture is not uniform, it's a heterogeneous mixture. If your mixture is uniform on the molecular or atomic level, it's a homogeneous mixture. If, on the other hand, your sample of matter cannot be separated physically, it is a pure substance. If that pure substance can be chemically decomposed, it's a compound, so one type of molecule, but more than one type of atom. If it cannot be decomposed, it is an element, which is only one type of atom. I hope this cleared things up, and I will see you on Wednesday.